Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science at Jesus and Mary College, University of Delhi. So friends, we have been talking about operating systems in the past few lectures, and in the last part of this lecture we were talking about how process management and process scheduling is achieved by operating systems and how inter-process communication occurs. So inter-process communication is a very important and interesting aspect of how processes, while they are executing, they communicate with each other, or they share some data or some information with each other. So those processes which are executing concurrently at any given time, they could be independent processes. In that case, they are not communicating with each other, they are running on their own, or they could be cooperating processes. So cooperating processes means that they are affected or they affect other processes. So this could include one aspect like sharing of data. Now there could be many reasons why processes should cooperate. So one major reason why processes cooperate is information sharing. As we just said, it is like data sharing, that processes, there is some common data which they want to access, and therefore they communicate with each other, or there can be interleaving data, that is the data from one process is required by the other process, so they may be transferring that data. Another reason why processes cooperate or communicate with each other is computation speed up. That is, two processes, when they are closely associated or they belong to one major task, so then they can run and they can communicate with each other, so that the overall computation speed of the entire application is increased. Then we have modularity, because we know that sometimes applications are designed in modular format, that is, individual task of the application is assigned to different modules, so those modules can be run on different processes. So that is another aspect why processes will cooperate with each other, or why processes need to communicate with each other. And of course, convenience is also one of the important factors which is important for communication between the processes. Now when we talk about inter-process communication, so inter-process communication, there are two models or two modes, we can say, in which inter-process communication is taking place. So first model or first mode is using the shared memory. Now in shared memory, basically a region of the memory, the main memory of the computer, is shared between cooperating processes. So this kind of arrangement or this kind of area is a mark which is actually exchanged by, which can be read and which can be written by two different processes. So this is one way. The other way is using message passing. So message passing means that messages are exchanged between the cooperating processes, that is, they send and they receive messages from each other. So shared memory we had discussed in the last series of the lecture, also last part of this lecture series, and now today we are going to talk about how message passing occurs. So now when we are talking about message passing, it's very important to understand the concept of naming, right? Because when we want to communicate with somebody, right, even when human beings are communicating with each other, they need to refer to each other, right? And how do we refer to each other? We refer to each other by our name, right? To draw somebody's attention, you call out their name and then they understand that okay, you want to communicate to them. Same way in process sharing also, every process it needs to have a unique identifier, it has a unique name, we say, right? So when the processes they want to communicate with each other, they will refer to each other with this name. Now this communication could be a direct communication or it could be an indirect communication. Now what is direct and what is indirect? In direct communication, the process that wants to communicate will explicitly name the recipient or sender of the communication, right? So basically in this we have the send and receive primitive. Send and receive primitive means these are like function calls, and in this they will call out the process with its name, right. So, for example, this example says that if I want to send a message to process P, so I will call out the send primitive, in which I will write the name of the process to which I want to send, say the P, and the message. Likewise, if we want to receive a message from a process, say Q, so I will call the receive primitive and I will give the name of the message, say Q, and I will give the message. So, this way, this is a direct communication which is happening between processes where they are referring to each other by their proper names, right. Now, a communication link, in this case what we have seen, a communication link will have various properties, right. Now, what are the properties which a communication link needs to have when it is a direct communication? That is, a link needs to be established between every pair of processes that want to communicate, right, and the process should know each other's identity to communicate, that is, they should know each other's name. Now, when a link is established, it is associated with exactly two processes. That is, you have two processes, in between there is one link, and that link will belong to two processes only, and there will be only one link between any two processes. So, two processes that want to communicate, they will have a single link, and one link will facilitate communication between those two processes only. When we talk about indirect communication, in this messages are not sent directly to the sender or directly to the receiver, but they are sent or received to mailboxes, or we can say the ports. Now, mailbox is, it can be looked at as an abstraction where, it is an object in which messages are placed by processes and from which messages can be removed. So, now again here also the mailbox will have a unique identification. So, you can understand this something, close to our emailing box, where a person who wants to talk to you is not calling you directly, but sending it to your mailbox, sending it to an abstract object called the mailbox, in which the communications are stored, from which the communications can be read, and the communications can also be removed from that. So, this kind of a structure is an indirect communication structure. Now, in an indirect communication link, the communication link should, it definitely needs to be established between a pair of the processes, and it is only possible when they share a common mailbox, right. So, they both the members of the pair which are communicating, they need to have a mailbox. Then a link is associated with more than two processes. So, we had seen in direct communication, a communication link was associated with only two processes, but here it is not like that, it is associated with more than two processes, and between each pair of communicating processes, a number of different links may exist, with each link corresponding to one mailbox. So, if process P1 and process P2 are communicating with each other, it is not necessary that a link L1 will only exist between them. There can be multiple links L1, L2, L3 which are linking the two processes, and each link will correspond to one mailbox. So, the sender can send the message or the communication through any of the links through the designated mailbox. So, this is how process communication takes place and how direct and indirect communication takes place. Now, another very significant aspect of inter-process communication is synchronization. Now, synchronization basically when processes are communicating with each other, so they are as we just saw that they are having calls like the send call and the receive call. Now, there are different options for implementing these send and receive calls, and message passing between two processes could be either blocking, that is synchronous, or non-blocking, that is asynchronous. So, if we take the analogy of communication systems. So, we remember that synchronous means that both the sender and the receiver are available when the communication is taking place. Asynchronous means that they can initiate the communication and then they can switch on to the next task. So here also, when we are saying that two processes are communicating with each other in a synchronous mode or in a blocking mode. So when we say that it is a blocking send, then this primitive means that the sending process is blocked until the message is received by the receiving process or by the mailbox. So when a process sends a message, it will block there till the time it gets an acknowledgement that the message has been received by the other process or has been transferred to the mailbox. Then we can have non-blocking send, in which the sending process will just send the message and after that it will resume its operation, it will not remain in the blocked state. Then we have the blocking receive, in which the receiver will block until a message is available. So the receiver will get to know that a message is awaited and it will block till the time the message is coming. And non-blocking means that the receiver retrieves either a valid message or a null. So it is not going to stop, but it is only going to retrieve when the message is coming. So this is about, how synchronized how synchronous and non-synchronous communication can happen between the two communicating processes. Then another very important aspect of inter-process communication is buffering. So buffering basically, buffering means to store or to keep the data or to keep the message which is in transit, right. So when communication is happening, either it is direct or it is indirect, that is messages are being exchanged by processes, they reside in a temporary queue. We can say that there is a temporary area in which the message will reside till the time it reaches its final destination. Now this queue, what we are saying, or this buffer, what we are saying, it can also be implemented using three different ways. So the first way or the first type of queue is a zero capacity queue. Now zero capacity queue means that the maximum length of the queue is 0. Zero length means that the link cannot have any messages waiting in it. So as soon as the sender sends the message or as soon as the sender blocks it, the receiver will receive the message. So zero capacity queue is actually only occurring when you have the synchronous mode of communication. So when the sender sends the message, the receiver is into a block receive and then the message is transferred. So this is a zero capacity queue. Then we can have a bounded capacity queue also. Now bounded capacity means that the capacity of the queue will have a finite length. Say the length is n. So n means that at most n messages can reside in the queue. So if the queue is not full when a new message is sent, then the message is placed in the queue. Either the message is copied or a pointer. So the message can be placed or a simple pointer to the message can be placed in the queue. But if the message after the message has been put in the queue, the sender can continue execution without waiting. So this is like this is the asynchronous mode. Now once the link's capacity is filled, because we are saying it is a finite capacity queue. So once the capacity of the link is complete, it is becoming full, then the sender will block until the space is available in the queue. So till the time the space is not available, the sender will not be able to send the message because it is a finite capacity queue. Then next is unbounded capacity queue. So unbounded means that the length of the queue is potentially infinite, that is any number of messages can be transferred to it and the sender will never block. So the messages can keep coming and they can be added to the queue on a continuous basis. So likewise we see that there are three types of mechanisms for waiting of messages in the communication link. One is no wait or zero wait. As soon as the message is transmitted, it is received. Then we can have a bounded, that is for some time the message can wait but not an infinite time. And then we can have an unbounded, that is the messages can keep on accumulating till the time the receiver takes them. And there is asynchronous communication by the sender, that is the sender will push the message in the queue and it will continue, it will resume with the execution. Next is how communication will take place in client server system. So, we have seen how communications are taking place within different processes. Now, the processes they could be running on the same system or they could be running on different system. So, when we are talking about how communication is taking place in a client server system, we mean generally that the processes they are running on two different systems, and those two processes which are, one is running on the client system, the other is running on the server system, how these two processes, the remote processes, can also communicate to each other. So, for this basically there are three main mechanisms which work. So, the first mechanism is through sockets, the second mechanism is through remote procedure calls or what we call as RPCs very commonly, and the third mechanism is the mechanism of conduits or what we also commonly call as pipes. So, in these three we will see that how processes communicate with each other on remote machines, machines which are remote processes communicate with each other on different computers or different machines. So, the first mechanism is the socket mechanism. Now, socket basically this word is the socket word is actually coming from the connection, the physical connections. So, here it is a logical it is an end point for communication. So, basically we must have heard the the name port. When communication is happening, we always refer to the IP address and we say there is a port at which the communication is happening. So, this port basically is actually the IP address plus the port number is completely identified as a socket. So, socket means we give the IP address and we give the port number at which the communication is going to work. So, in this case when two processes are communicating over a network, right, so they will employ a pair of sockets. So, a pair of sockets means that one socket for each process, one socket for the server process, one socket for the client process, and then we specify the IP address along with the port number to identify the socket at which the communication is going to take place. So, when we are talking about say the client server communication using sockets. So, if there is a server which is waiting for incoming client request, so it is always listening to a specified port, and once a request is received on that port, then the server will accept a connection from the client socket to complete the connection. Now, basically this depends, the port as we know will depend upon the application. We have talked about this in networks also, that different applications they will connect on different ports. So, therefore, different processes will have different sockets at which they will connect, but all connections they have to be unique. That is, if another process, if you have a server on which a connection is taking place at say the port number 1624, right. Say in this diagram you can see that there is a host X and there is a web server, and on the web server the connection is taking place on a particular port by the particular from the host it is taking place at 1625. So, or 1624 say for instance. So, then the other connection which is going to take place will have to be something more than 1024, but something less than 1624. That is, the port number or the identity of the socket has to be unique. This is the idea. So, if there is already a connection and another process on that host wishes to establish with the same web server, then it needs to be assigned a port number which is greater than 1024 but not equal to 1625. Why? Because the IP address in this case, if the client and the server are the same, so the IP address will remain the same. So, how do you maintain that these are unique? You will have to change the port number. So, therefore, this will ensure that all connections will consist of a unique pair of sockets, whether they are from the same client or they are from the different host, right. So, next way or the next strategy in which client server communication can take place is through remote procedure calls. So, this is one of the most common forms of services which is the RPC paradigm that we talk about, and this is basically a way to abstract procedure call mechanism for use between system with network connections. So, if when we talk about inter-process communication, we mean that the processes are generally residing on the same system, but when we are talking about RPC, we are building the same system, we are using the IPC system as a base, and on that only, on top of the IPC system, we build the RPC system also, because in many respects the remote procedure call is very much similar or same as the inter-process communication mechanism. So, because now we are dealing with an environment in which the processes are executing on separate systems, right. So, therefore, we need to have a message based communication scheme to provide remote services, right. So, therefore, it is important that the message that is being exchanged in RPC, in the remote procedure call, they are more structured, and they are not just simple packets of data which is being sent as it was sent in IPC, but they are more structured and more properly packed packets of data as compared to the IPC messages. Now, in this case, in case of remote procedure call or RPC, each message is actually addressed to an RPC domain, now which is listening to a port on the remote system, and each contains an identifier, just like we had done in sockets. Here also, when we are having an RPC message exchange, then there is a unique identifier which specifies the function to execute and the parameters to pass to that function. So, basically the function is executed as per the request of the remote machine, and if any output is generated, that is sent back to the requester in a separate message. So, the basic idea of getting the system, getting the functions performed from a remote machine is same as was happening in the IPC, the only difference being that RPC is occurring on remote systems, and the structure, the packet structure or the way in which data is exchanged is more structured, it is more organized manner. Then the third type of mechanism or third type of strategy which is adopted for communication between a client and the server is basically using the pipes. Now, pipe, as the name itself suggests, it is a conduit. So, it is a logical conduit, we can say, which allows two processes to communicate. Now, pipe was actually it was the first initial IPC mechanism which was used in early Unix system, right, and after that it has been evolving and it has been changing, and we have newer strategies now, but this is one of the simplest ways in which processes can communicate to each other. However, pipes, they have their own limitations, but since it is a simple way of implementing, so therefore this has got gained popularity, and it still remains viable in many, it is being used in many operating systems. So, in implementing pipe, there are actually issues which need to be considered. So, first thing is whether the pipe is unidirectional or it is bidirectional. That is, it will allow communication only in one direction or in both the direction. So, it means that if you are having unidirectional pipe, then we need to have actually two pipes, because both the devices or both the processes may be a sender or a receiver. Then if we have a two-way communication, it is also important to know whether the communication is going to be half duplex, that is, data can travel only one way at a time, or it can be full duplex, that is, data can travel in both the directions at the same time. So, the important point to note is whether it is unidirectional or bidirectional. If it is two-way, if it is bidirectional, then whether it is half duplex or it is full duplex communication. Then we must also understand that whether there is a relationship which exists between communicating processes, like a parent-child relationship exists, that is, if one process terminates, then can the other process continue or not. Then also whether the pipes can communicate over a network or must be communicating processes reside on the same machine. So these four aspects need to be understood before we can use pipes as a mechanism for communicating between a client and a server. Now pipes are also of three types, basically ordinary pipes, which allow two processes to communicate in a standard producer consumer fashion. So producer consumer means that the producer will write to one end of the pipe, that is the write end, and the consumer will read from the other end, that is the read end. So therefore this makes these ordinary pipes unidirectional, that is only one way communication is allowed. So in ordinary pipe, as we just said, that if two-way communication is allowed, then we need to use two pipes with each pipe sending data in a different direction. So this is a very simple mechanism, and a pair of processes can communicate using this, right. Ordinary pipes will exist, they are communicating with one another. This was used in Unix and Windows systems, but now they cease to exist because of the requirement of two pipes. Then we can have another type of pipe which is called as the named pipe. Now named pipes provide a much more powerful communication tool because they allow bidirectional flow of information, and they do not have a parent-child relationship. So this named pipe, once it is established, then it can be used for several processes. So named pipe can also have several writers. So now this is commonly used in Unix and Windows supporting system. So this was all about how client and server communication can take place through sockets, through remote procedure calls, and through pipes. We will be continuing with our discussion. Till then, keep watching CEC. Thank you.